Assalamualaikum everyone. We are the Group 2 and I am Sitia Jaffa M. Moroho, and for today's video, we will be discussing all about cement. So our organization of content is number 1, what is cement? Number 2, history of cement. Number 3, cement manufacturing flowchart. Number 4, types of cement. Number 5, cement ingredients. Number 6, grade of cement. Number 7, the compressive strength bar chart of different types of cement. Number 8, properties of cement. Number 9, functions of cement. And number 10, testing of cement. So let's talk about cement first. So what is cement? Cement is one of the best binding materials in the construction industry that is used to reinforce the building units such as stones, bricks, and tiles. Cement is the finely powdered material that hardens when mixing with water. It is used worldwide in all types of constructions. There are more than 2,273 active cement production plants in the world according to the World Cement Directory. The cement usually mentions to a very fine, dusty substance primarily made up of limestone, calcium, clay, silicon, or sand, iron ore, and bauxite aluminum. May include some other admixtures like chalk, shells, shale, marl, clay, slate, blast, fornax slag. The top 3 producers of cement in the world are China, America, and India, where China contributes more than 45% in the cement industry. So, ang cement daw or ang semento ay isa sa pinakamahusay na material sa industriya ng construction. Ito ay ginagamit upang palakasin ang mga unit ng gusali kagaya ng bato, stones, or ang bricks. Ang cement ay pinungpulbos or finely pulverized, in simple term, powder, na kapag pinaghalo sa tubig ay titigas. Ginagamit ito sa buong mundo sa lahat ng construction. So, cement is defined as a hydraulic binder, an excellently crushed inorganic material which, when mixed with water, forms a paste which sets and hardens by means of hydraulic reactions and processes in which, after hardening, retains its strength and stability even underwater. The cement can be defined as the bonding substantial possessing cohesive and adhesive possession which mark it capable to band the diverse construction materials and form the compressed unit. Simply, in terms of concrete, cement is an adhesive that is used to bind sand and aggregates to make concrete. So, ang cement is ang hydraulic binder na kapag hinalo sa tubig ay titigas or magpo-form siya ng paste. So, by means of hydraulic reaction, hydraulic means affected or move by means of water. So, kapag tumigas yung semento, kahit ilagay mo siya sa ilalim ng tubig, hindi siya matutunaw or hindi siya lalambot. Next, history of cement. So, cement is being used as the binding materials throughout the history. In earlier, Romans used lime as the cement binding material. They also used to form the hard mass cement by the reaction of the lime with the volcanic ash in the presence of the water. After this, Portland cement was started using after its discovery in 1824. So, ang semento ay ginagamit bilang material na nagbubuklod sa buong kasaysayan. Noong una, ginamit ng mga Romano ang limestone bilang material na nagbubuklod ng semento. Nabuo din nila ang matigas na mass o semento sa pamamagitan ng reaksyon ng lime with the volcanic ash in the presence of water. Pagkatapos nito, sinimulan ng gamitin ang semento ng Portland matapos itong matuklasan noong 1824. Joseph Aspdin grabbed out the patent in 1824 for Portland cement, a material he formed by heating finely ground clay and limestone and ground mixture until it became a powder. He called it Portland cement because the concrete made from it looked like Portland stone, a widely used building stone in England. So, si Joseph Aspdin ay nakakuha ng isang patent noong 1824 para sa Portland cement, isang material na kanyang nabuo sa pamamagitan ng pag-init ng pinong lupang, luad o clay at limestone na dinurog at pinaghalong hanggang sa maging pulbos. Tinawag niya itong Portland cement dahil ang konkretong ginawa mula rito ay parang Portland stone, isang malawak na ginagamit na bato na gusali sa England. Nang maglaon noong 1845, inihanda ni Isaac Johnson ang unang bagong semento ng Portland sa pamamagitan ng pag-init ng kombinasyon ng chalk at lime sa mas mataas na temperatura katulad ng mga ginagamit ngayon sa isang araw. Next is cement manufacturing flow chart. So the basic three material used in production to produce a cement is number 1, clay, limestone, and sand. So these three is the first we need to produce a cement. So they are being taken in the crusher, and then the secondary crusher, and then the proportioning equipment, and they are being ground in a grinding mill, and after that they heat at 1450-degree kiln. So after they are being heat in the preheater tower, so after combining them, they will form a clinker. And then the clinker is being passed and then they cooled. After clinker is being cooled down, there is gypsum. And this is being added to the clinker, and usually cement is 95% of clinker and 5% in gypsum. And then clinker and gypsum are added together. They will be grounded, or they are being grinding in a machine. So while they are grinding, that's when you produce a cement.
Portland cement. Cement is manufactured by two methods. They are 1. Wet process, 2. Dry process. Now, let us discuss wet process and dry process in detail. Wet process. In the wet process, first, the clay is purified by washing in a wash mill. The limestone is crushed into small particles and mixed with purified clay in proper portions to get raw slurry. Dry process. In the dry process, the raw materials are mixed in proper proportions. The mixture is dried, pulverized, crushed into fine particles and made uniform. The resulting powder is called raw material. The raw slurry or raw meal obtained by one of wet or dry process called charge. Charge is introduced into a rotary kiln. A rotary kiln consists of a steel cylinder about 150 meters long and 4-meter diameter and rotates 30 to 60 turns per hour. At one end of the cylinder, a screw conveyor is arranged which slowly allows the charge into the cylinder. The other end of the cylinder, a burner is arranged. Coal or burning oil is burnt at this end. The charge entering the cylinder slowly moves towards the hot end. At the burning end of the kiln, the temperature is around 1700 to 1900 degrees centigrade. At this end, some chemical reaction takes place between calcium oxide and aluminium silicates. Mixture of calcium silicates and calcium aluminates is formed. The resultant product consists of grey hard balls called clinker cement. Clinker cement is cooled, ground to fine powder and mixed with 2 to 3% of gypsum.
There are various uses of cement in the construction industry, depending upon the use and the strength required. There have been many types of cement developed by the researchers. So we have 11 types of cement. The first type of cement that I will introduce to you is the ordinary Portland cement, or the OPC. This is the most widely used type of cement because it can be used in all construction such as concrete buildings, bridges, and others. OPC consists of tricalcium silicates or C3S and dicalcium silicates or C2S, tricalcium aluminate or C3A, and tetracalcium alumino or C4AF. The second type of cement is the rapid hardening cement or RHC. As the name indicates, rapid hardening cement is built to gain strength and hardens more quickly. Its strength is the same in 3 days as of OPC in 7 days. RHC used for roads or highways construction for early strengthening so that the roads or highways can be available early. In cold weather countries, RHC is used because RHC has high heat emission rate and develops high early strength. The number 3 type of cement is the Portland Pozzolana cement or PPC. It is very fine cement and it can be used for plastering works like in the hydraulic construction, marine structures, dam construction, and others. The fourth type of cement is the quick setting cement or QSC. QSC is a binding material. Its main attribute is its fast setting time, which can harden in a time ranging of 20 minutes to 40 minutes. It can be useful in a cold weather or rainy condition. The fifth type of cement is the low heat cement or LHC. LHC majorly used in constructing dams, large footings, large raft slabs, wind turbine plinths, and the advantage of low heat cement is assisting in minimizing the potential for thermal cracking in a thick concrete sections. And the sixth type of cement is the sulfate resisting cement. The use of SRC provides excellent protection against the formation of sulfo-aluminates and consequent resistance to concrete against the sulfate attack. It has very high compressive strength by economic concrete mix design and very low heat of hydration to helps to avoid shrinkage cracks.
So there are other types of cement. First is high alumina cement, white cement, air-entrained cement, hydraulic cement, and hydrographic cement. So first is high alumina cement. High alumina cement was first industrialized in United Kingdom in 1925. Alumina cement is contrived by crushing the clinkers of alumina and calcareous materials such as laying by combining or sintering procedure. It can be used in marine construction due to its durability. High alumina cement or HAC, also known as calcium aluminate cement or CAC or aluminous cement, was manufactured by Lafarge, the cement producer. It was first used in the United Kingdom in 1925, like what I've said. Afterward, it is used in France where it had been developed earlier to make concrete resistant to chemical attack. So, high alumina cement was first introduced or was first used in United Kingdom in 1925. So after that, so many years ay umabot din ito sa France, which is ginamit na rin ng France. Pero pagdating nito sa France, i-develop nila ang high alumina cement, which is may dinagdag sila na pang resistance sa chemical attack. Kasi dati, nung andito pa siya sa United Kingdom last, ay resistant to heat lang ang kaya nitong resistance of heat lang. So, yun nga, pagdating sa France ay gi-develop nila or gi-upgrade, dinagdagan pang resistance sa chemical attack. So dati, yung sa United Kingdom, last 1974, may nag-collapse dun na high school na gawa sa high alumina cement. So that time, ang BRE or Building Research Establishment ang nag-start mag-study patungkol doon sa building na yon na gawa sa high alumina cement. So napag-alaman nila na ang cement ay ang concrete na gawa sa high alumina cement ay hindi tumatagal ng maraming taon, which is few years lang ang kaya nito, kasi napag-alaman nila na habang tumatagal yung concrete na gawa sa high alumina cement ay unti-unting nababawasan ang strength nito, kaya few years lang ang kaya nito, or kaya ng tibay, kaya ng concrete na ito na gawa sa high alumina cement. So, kasi kung pagbabasihan rin naman kung paano nagawa ang high alumina cement ay parang pinaghalo-halong mga clinkers of alumina, or may nilagay din sila ng soil and ibang uri pa ng abo, which is hindi gaano kalakas yung resources na pinagmula nito kung paano at kung paano ito nagawa, kasi noong ginawa nila ito without melting, tapos pinatuyo lang siya sa araw. So high alumina cement, it is mostly used in marine construction, in sewer infrastructure due to its early strength gaining property. It is also extensively used in making refractory concrete where it has to deal with high temperature. So yun nga, ito yung cement na pwedeng gamitin sa mga high temperature na lugar, yung may matataas na temperatura. It is widely used for the manufacturing of concrete and precast concrete beams. So pwede siyang gamitin, yun nga lang, hindi siya highly recommended, or hindi siya highly recommended, pero yung klase ng cement nito ay hindi tumatagal ng maraming taon. Let's just say na 8 years lang yung minimum na years na tinatagal ng concrete na gawa sa high alumina cement. So next is white cement. Portland cement is prepared by mixing the white aggregates with the ordinary Portland cement. It is prepared by the raw material containing very little iron oxide and manganese oxide. Its color is very much appealing from the architectural point of view. So it is readily available throughout North America. So yun nga, white cement, which is pinaghalo lang siya na white aggregates, and Portland cement, or yung ordinary cement na ginagamit natin. Due to its whiteness, it is used in architectural beauty, interior and exterior decoration, floorings, and ornamental concrete products. So based sa architectural point of view o sa mga architectures ay mas para sa kanila maganda itong gamitin, kasi bukod sa cement, nakakagawa ito ng concrete, nakakadagdag ito ng design or decoration sa isang concrete, kasi ngayon puti siya, which is maliwala siya tingnan, pero yun nga, para sa kanila maganda itong gamitin kasi nakakadagdag ng design. This also utilized roots due to the property of high reflectiveness to give the best visibility in highway medians. So pwede rin to siyang gamitin sa mga kalsada, kasi ngayon puti. Kahit sa gabi siya, maliwanag tingnan ang kalsada, kasi ngayon puti, nagre-reflect yung kulay niya na puti. So yun, para sa kanila pwedeng gamitin sa kalsada. It is a relatively costly cement type and it's therefore utilized in only choose. So this kind of cement, bukod sa nakakadagdag siya ng decoration, based yun sa architectural point of view, kasi ngayon puti siya, white, may appeal yung kulay niya. So but in terms of strength rather, ay mas malakas naman yung strength ng ordinary cement na ginagamit natin. At reason pa, ang disadvantage pa nito is mahal kung kumpara sa ordinary cement na ginagamit natin. So yun nga, ang white cement gamitin lang talaga siya pag kailangan, kasi mahal siya, pero mahal siya, bukod pa doon mas malakas pa yung ordinary cement na ginagamit natin. So yung white cement din ay maaari siyang gamitin sa mga lugar na may high temperature kasi mayroon din siyang resistance to heat. So next is the air entraining cement. Or air entrained cement is the type of cement in which air bubbles have been introduced rather. It can be used with the good results for a variety of conditions. It has been established to yield concrete that is resilient to freeze-thaw action and to climbing produced by chemicals applied for severe frost and ice removal. So it is a kind of cement, or it is a special cement which has air bubbles introduced in the cement or concrete that provides the space for expansion. The workability of the cement is high due to the air bubbles which act as lubricant between aggregates, which reduce water and sand requirement and hence increase in strength of the concrete. So, but it is difficult to attain high level of strength concrete with air entrained cement. So, this kind of cement, ito yung cement na nagpo-produce siya ng bubbles, or the time na na-make siya, nagpo-produce siya ng bubbles. Then, advantage din nun, yung produce niya na, yung lumalabas ng mga bubbles dun sa cement na yun is, napapadali yung pag-mix pag nadagdag together with aggregates in sand or in water. Pag na-mix-mix na siya, nakakatulong yung mga bubbles na yun para mapadali yung pag-mix kasi nagpo-produce or nagiging oily yung bubbles na yun. At the same time, in terms naman sa strength, kung gaano kalakas yung concrete na gawa sa air entraining cement ay hindi siya ganong kalakas kasi once na matuyo yung cement na gawa sa concrete na gawa sa air entrained cement, yung mga bubbles or cause ng bubbles na naiwan nun ay nag-iwan siya ng mga small spaces dun sa concrete na yun, which is nagiging dahilan nito or madali siyang tagusan ng tubig. Madaling tagusan ng tubig yung concrete na yun kasi may naiwan na mga species doon cause of bubbles. So habang tumatagal yung mga bubbles na yun ay lumalaki yung expansion, nag-i-expand siya yung bubbles na yung shape na cause ng bubbles. So, habang tumatagal, habang lumalaki yung mga species na yun, small species na yun, ay nababawasan rin yung bigat ng isang concrete na gawa sa air entrained cement. Kasi, yun nga, lumalaki yung mga species doon habang tumatagal. So, at the same time, or may tendency na madaling lumambot yung concrete na gawa sa air entrained cement kasi ngayon habang lumalaki yung species na cause ng bubbles ay mas marami din yung tubig na natatambay doon, which is may tendency na mapalambot niya yung concrete na yun na gawa sa air entrained cement. So that's why yung mga gawa sa concrete na air entrained cement ay hindi siya gano'ng kalakas, yun nga kasi hindi siya habang tumatagal ay lumalaki yung mga species doon na cause ng bubbles na yun. So at the same time, this kind of cement ay mayroon siyang sulfate resistance, or nare-resist niya or may resistance siya in sulfuric acids. The use of air entrained cement increases the prosperity concrete, thereby reducing the unit weight. Yun nga yung sabi ko na maaaring habang tumatagal ay lumalaki yung mga species na yun na cause ng bubbles, which is habang tumatagal ay nababawasan niya yung bigat ng isang concrete na gawa sa air entraining cement. So next is hydraulic cement. Hydraulic cement can be used to stop the entrance or flow of the water in the concrete or other structures. It can be used in swimming pools and foundations. Hydraulic cement is a product used to stop water and leaks in concrete and masonry structures. It is the type of cement similar to mortar that is extremely fast and hardens after it has been mixed with water. So, this kind of cement, ito yung cement na na-stop niya or nai-resist or na-stop niya yung flow ng water o hindi ito yung cement na hindi madaling tagusan ng water kasi ngayon na-stop niya yung flow ng water. So this kind of cement ay once na ma-mix din siya, ito yung madaling tumigas na cement within 3 minutes or more than 3 minutes. Tapos, tumitigas na ito. Or, hindi naman totally tumitigas, pero yun yung minimum niya na dali ng pagtigas ng cement na to. It is used widely in the construction industry, selling structure below grade, and in situations where structure can be affected or submerged in water. So, in simplest term, ito yung cement na ginagamit sa mga concrete na madalas may contact sa water or ito yung ginagawang concrete sa mga lugar na madalas may contact sa water. Like for example na lang is swimming pools, cisterns and fountains, marine application, drainage systems, foundations, and basement walls. So, nagagamit din yun sa foundations, sa mga foundations, kasi ngayon, sa ilalim ng lupa, alam naman natin na may tubig talaga dyan, kahit hindi naman sa totally nakikita natin, pero may basa din yan or may tubig din yan sa baba or sa ilalim ng lupa. So, that's why pwede din siyang gamit sa mga basement walls, kasi ngayon may resist in flow, may resistance siya to in water or pag na-stop yung flow ng water. So yun nga yung sabi ko, ito yung madalas ginagamit na cement sa mga always na may contact sa water. So the last types of cement is the hydrographic cement, or it also known hydrophobic cement, comprises the admixtures which have the ability to decrease the wetness of cement grains. The frost resistance in hydrophobic cement is very much high as compared to the others due to the uniform distribution of the fine pores. So this kind of cement or hydrophobic cement, from the word itself, hydrophobic or hydro, means water, phobic means against. So, parang same lang din siya sa hydraulic cement na na-stop din niya or hindi siya madaling tagusan ng tubig na cement, which is ang concrete na gawa sa hydrophobic cement ay hindi rin siya madaling tagusan ng tubig. So, parang same lang din siya sa hydraulic cement na may resistance siya in water. So, ito yung this kind of cement majorly used in the tunnel construction as the underground repairs are difficult and costly. So yun nga, madalas siyang ginagamit sa tunnel construction. Yun nga yung sa tunnel kasi di ba yung ginagawang mga tunnel yung mga ginagawang tunnel and also in the underground. So ito yun nga, same lang siya sa hydraulic cement, pero yung hydrophobic cement ay may kamahalan din siya na cement. May kamahalan din siya na cement compared sa hydraulic cement. It is used also in structure that are exposed to rain or rain puddling, such as green roofs, other kind of roofs, parking structure, and plazas. Yun nga, madalas siyang ito yung madalas na ginagamit sa mga always may contact sa tubig. Kasi ngayon nga sabi ko, same lang siya sa hydraulic cement. So, the ability increase of cement. Yun nga yung ability niya, may frost resistance is very much high compared to the others. So, ito ay pwede siyang gamitin compared naman sa hydraulic. O nga, same sila sa hydraulic na may resistance in water, pero itong hydrophobic cement ay maaari siyang gamitin sa country or sa lugar na madalas nag-yellow or may nag-snow. Kasi yung resistance niya and kuan sa mga malalamig na lugar ay mas high, very much high compared sa other na uri ng cement. So, yun. In terms naman sa strength niya, ay same lang din siya sa ordinary cement na ginagamit natin. Kaya, pwede rin siyang, hindi naman, pwede rin siya ma-recommend na gamiting cement kasi bukod sa kapareho lang niya ng strength yung ordinary cement na ginagamit natin or yung nakasanayan natin, ay may resistance in water din siya. Hindi siya madaling tagusan ng water. So, yun lang, and thank you.
Assalamualaikum, I am Aslam Pandaw, and let's move on in cement ingredients. Cement ingredients, number 1, lime. Lime ingredients, lime. Lime has 62% in cement. The function is to impact strength. The efficiency can decrease the setting time. So, it can decrease the setting time on the lime. So, number 2, silica. Silica has 21% in cement. So, the function is to impact the strength. So, silica is the function to impact the strength. Number 3, alumina. Alumina has 5% in cement. The function is to impact the quick setting of the cement. Number 4, magnesium. Magnesium has 1 to 3% in cement. It should not be more than 2%. So that is magnesium. Number 5 ingredient is iron oxide. Iron oxide has 0.5% in cement. The function is to impart color to cement. So iron oxide is to impart color to cement. So iron oxide is the imparts to color of the cement. Caso number 6, Caso 4. It has 0.1 to 0.5% in cement. So Caso 4 it has 0.1 to 0.5% in cement, and the function is can slow down the setting time present in cement as gypsum. Number 7, sulfur trioxide. Sulfur trioxide has 1 to 3% in cement. The function is the soundness of the cement is due to sulfur trioxide, which should not be more than 2%. So number 8, alkaline. Alkaline has 0.0 to 1% in cement. The function is should not be more than 1%. So there are 8 ingredients of cement. Now, lime, silica, alumina, magnesium, iron oxide, Caso4, sulfur trioxide, and last, alkaline. So thank you.
Grade of cement. Cement is divided into 3 grades. The grade 33, the grade 43, and the grade 53. The grease grade measure the strength of the cement after the strength of cement is measured by the comprehensive strength. So the comprehensive strength is the strength of cement molded into standard cube after 28 days of curing. So first grade is the grade 33. The grade 33 has a comprehensive strength of 33 megapascal after 28 days of curing. This type of cement is cast off for general construction work under normal environmental conditions. So nowadays, grade 33 cement is rarely used because most of the manufacturers have shifted to PPC. This grade is commonly used for making concrete of low strength. So the second is the grade 43. The grade 43 has the comprehensive strength of 43 megapascal after 28 days of curing. This type of cement is cast off for plain concrete works and plastering works. This grade 43 cement is used for PPC and RCC works, preferable where the grade of concrete is up to M30. So PPC po is standard for plain cement concrete which is there is no bar steel are used. Ang RCC naman ay ito yung mga reinforcer which is merong mga steel bar na ginagamit. Grade 43 is also recommended for plastery, tiling, brickwork, and stone masonry, flooring, and pathway, and etc. So, third is the grade 53 cement. Grade 53 cement has a comprehensive strength of 53 megapascal after 28 days of curing. It usually first constructor dedication as in reinforcement cement concrete. This kind of grade cement is recommended for RCC structure like footing, hollow, beams, and slab where initial and ultimate strength is major structural requirements. So, itong grade 50 ang usually ginagamit kayo. Mas higher kasi ang strength ito kumpara sa grade 33 at grade 43. Each cement grade is specific for its use. The use of cement grade is for every type of construction can affect the structure durability and strength. Every grade of cement is suitable for a different set of tasks. Each of them has a barrier level of different using the wrong strength level of particular job can affect your overall construction design.
Assalamualaikum and good day everyone. I am Omar B. Abunawas and I'm here to share you about the comparative compressive strength bar chart of different types of cement. So, before we discuss the bar chart, what is compressive strength? So, a compressive strength refers to the ability of a certain materials or structural elements to withstand load that reduce the size of that materials or structural elements when applied. A force is applied to the top and bottom of a test sample until the sample fractured or is deformed. So, as you can see sa bar chart, it shows that tatlo lang yung ginamit niya na type of cement. Makikita nyo na OPC, which is ordinary Portland cement, and PPC, Portland pozzolan cement, and PSC, Portland slag cement. So, in 28 days daw, ang nakaya ng ordinary Portland cement na compressive strength is between 40 to 45 megapascal. So, in 90 days naman, ang nakaya niyang may comparative compressive strength or compressive strength pala is between 45 and 50 megapascal. So, dito sa bar chart na to, ipinapakita dito kung anong kayang strength or anong kayang ability ng isang anong kayang gawin or gaano kabigat ang kayang dalhin ng isang kind of cement. Like sa PPC or Portland pozzolan cement, in 28 days, ang nakaya na ng compressive strength is 40 to 45 megapascal. So, same lang sa OPC. Sa 90 days naman sa PPC is 40 to 45 megapascal. So, PSC, hindi siya na-discuss sa ibang kinds or sa kinds of cement. So, ang PPC is Portland slag cement. So, ang Portland slag cement naman is a blended cement because composed of Portland cement, clinker, and gypsum, wherein some portion of ordinary Portland cement is replaced without ground granulated blast furnace slag or GGBS to make the structure more long-lasting. So dito sa comparative dito sa compressive strength, pinapakita dito na ang isang type of cement is ilang load yung kaya niyang dalhin. Ito yung pinapakita dito sa bar chart. Kaunting kaalaman about compressive strength. So as you can see, we have formula for compressive strength. Compressive strength is equals to maximum load in Newton divided by cross-sectional area in millimeter squared, wherein 1 kilonewton is equals to 1,000 newton and 1 centimeter squared is equals to 100 millimeter squared and 1 newton per millimeter squared is equals to 1 megapascal and 1 kilogram is equals to 9.81 newton. So example, given na yung cross-sectional area at we assume the compression load. So ang cross-sectional area natin na ginamit dito is yung cube sample test, wherein ang measurement ng cube is 150 by 150. So alam naman natin na ang cross-sectional area ng cube is side times side or side squared. So ita-times mo lang yan, magiging 22,500. So yung pangalawang given natin is assume the compression load is 450 kilonewton. So i-convert natin yan into newton kasi ang compression strength is ang unit niya newton per millimeter squared. So find the compressive strength. So compressive strength 450 i-convert natin into newton. So ilalagay natin sa denominator yun. 1 kilonewton is 1,000 newton. Ilalagay natin yung 1 kilonewton sa denominator para ma-cancel out yung kilonewton, para ang matira na lang dito is newton. So divided by naman sa cross-sectional area, 150 mm and 150 mm. So 450 times 1,000 is equals to 450,000 newton over 22,500 mm squared. I-divide mo lang yan, ang magiging result is 20 newton per millimeter squared or 20 megapascal. So it shows that ang makakaya ng cube sample test na ang side niya, ang measurement ng side niya is 150 by 150 at saka yung maximum load niya na nakaya is 400 kilonewton. Yung compression pala na ang makakaya ng compressive strength is 20 megapascal.
Good day to each and everyone. My name is Ahmad Ryan and Makadindang, and I'm here to discuss the properties of cement. So there are two basic properties of cement. The first one is physical properties and the second one is chemical properties. Now chemical properties is just the ingredients that are used to make the cement. So there's nothing more to discuss in chemical properties because chemical properties was discussed by my other group member. Now let's proceed to physical properties. So first type of physical properties of cement is the fineness. Fineness reaction is the reaction between the water and cement takes in the surface. Greater the surfaces, greater will be the hydration and strength of cement. So this definition that I have read you is that this is just the effect when you are testing for the fineness of cement. But in simpler terms, fineness can also be defined as the size of the particles of cement, o ito yung pagkapino ng isang semento. So the next one is the hydration. Hydration, when water reacts with the cement, heat releases, and the process is known as hydration of the cement. It adds strength to the binding material. In hot condition, dissipations of heat can cause several shocks. So ganun din yung definition nito, no, na ito yung effect kapag tinetest mo yung isang cement by hydration, no. Pero since we are just discussing the physical properties of cement, so I'm just here to define these terms, kasi there is a separate topic for testing of cement. So hydration is just basically the chemical reaction when water interacts with cement. So ganun lang kasimple ang hydration, no. Ito yung nangyayari sa chemical ng isang cement kapag nahahaluan ito ng tubig. Itong process na to is tinatawag na hydration. So the next one is setting of cement. Setting of cement. So ito, setting of cement is just setting of cement is just the time, no? It's just the time in the hardening process which is accountable for its strength, known as the setting time of the cement. So yun ang setting time of the cement, and the process itself, yung process mismo, is tinatawag na setting of cement, or dito yung maybe in other terms curing time. No, usually it takes 1 to 2 days kung yung bago matapos yung setting of cement. Pero itong time na 1 to 2 days, pwedeng maapektuhan base sa isang fineness ng semento, cement water ratio, at saka marami pang iba. Yun yung pwedeng makaapekto sa setting time ng isang cement. The next one is soundness of cement. Soundness of a cement, the ability of the cement to resist the shrink after the hardening is known as the soundness of cement. So from the definition itself, no, ito lang naman yung kakayahan ng isang semento para hindi malubog pag inaapakan, o yung ability niya para mag-resist ng force, no. So yun lang sa soundness of cement. So the next one is the strength of cement. So there are 3 types of strength of cement that are used: measures, compressive, tensile, and flexural. So malalaman mo kung compressive, tensile, and flexural kung through grading of the cement, kung ano ba yung strength ng isang cement. Pero no, may mga bagay na nakakaapekto sa strength ng cement habang ginagawa ito. Yung iilan dito is yung water cement ratio, no? Yung paghalo, kung gaano kalaki yung tubig at semento pag pinaghalo is pwedeng makaapekto sa strength ng cement. Also, yung fineness ng cement and yung fineness ng aggregate na gagamitin. yung cement fine ratio, yung cement and fine aggregate ratio, and curing condition. So, iilan lang to sa mga bagay na pwedeng maka-apekto sa strength ng cement. And the next one, or should I say the last one, is the specific gravity. No, the specific gravity. The formula for the specific gravity is equal to weight of a given volume of cement. So ito daw yung given volume of cement over or divided by the weight of an equal volume of water, no? So ang specific, so bakit nga ba na considered na property ang isang specific gravity? Kasi for what I understand, no, it is an important property of cement, mainly because it is one way to determine the density of cement. Since ang mixing is based on weigh batching, no, so also the dense cement offers greater strength and less void when turned into concrete. So that's all for the properties of cement.
Function of cement. Cement is used to prepare the mortar. Ang ingredients ng mortar is water, sand, at saka cement. Ang isang halimbawa nito ay ang paggawa ng hollow blocks at saka yung pag-finishing ng isang wall. Cement is used to prepare the concrete. Ang cement daw ay ginagamit din sa paggawa ng konkreto. Used to bonding materials, paggawa ng mga bonding materials, like for example is yung mga poste or something else. Used for construction of cement, concrete road. Ang cement ay ginagamit din ito sa paggawa ng mga kalsada. Can be used as a fire resistant. Ginagamit din ng cement para mas mapalas yung sunog. Kasi yung semento ay mahirap kapitan ng apoy. Cement is used in the building of significant engineering construction such as bridges, culvert, dams, tunnels, and lighthouses. Ang cement ay ginagamit din ito sa paggawa ng mga buildings, tsaka mga bridges, tulay, tsaka dams. Cement can be used as a fire resistant by adding suitable admixture to it. Yun na nga, yung cement ay mas nakakalas siya ng sunog kasi hindi siya madalas kapitan ng apoy. Cement is cast off for creating joints for drains and pipes. Ang cement ay ginagamit din ito sa paggawa ng mga pipes sa mga drainage. Cement can be used to preparation of the foundation. Alam naman natin ang cement ay ginagamit din ito sa paggawa ng foundation ng isang bahay. Cement is used to harden the surface to protect against the different atmospheric condition. Ang cement din ay nakakaprotekta din ito sa mga paparating na atmospheric condition. Like for example is yung bahay mo ay semento, mas nakakaprotekta siya sa surface kapag may parating na malakas na hangin.
Assalamualaikum and good day everyone. I am Omar B. Abunawas and I'm here to discuss you about testing of cement. In testing of cement, we have two categories. We have laboratory test of cement and field test cement. So in laboratory test of cement, we have strength test, fineness test, seating time test, standard consistency test, heat of hydration test, soundness test, tensile strength test, chemical composition test. So we are going to show you a video about this laboratory test of cement.
लेबॉर्ट्री टेस्ट ऑफ सीमेंट में सबसे पहला टेस्ट होता है फाइनेस टेस्ट ऑफ सीमेंट का। इस टेस्ट में हम सीमेंट की फाइनेस को मेजर करते हैं। सीमेंट की फाइनेस रिस्पॉन्सिबल होती है रेट ऑफ हाइड्रेशन, हीट ऑफ हाइड्रेशन और रेट ऑफ गेन स्ट्रेंथ के लिए। जितना ज़्यादा सीमेंट फाइन होगा उतनी तेज़ी से हाइड्रेशन होती है और जितनी फास्ट हाइड्रेशन होगी उतने ही तेज़ी से वो स्ट्रेंथ गेन करता है। लेकिन ज़्यादा फाइन सीमेंट की सेटिंग भी क्विक होती है, इसलिए इसके पार्टिकल साइज़ को लिमिटेड रखा जाता है। सीमेंट की फाइननेस दो मेथड से मेजर की जाती है, सीव एनालिसिस एंड एयर परमिबिलिटी टेस्ट, और इस वीडियो में हम सीव एनालिसिस को डिस्कस करेंगे। फाइननेस टेस्ट के लिए हमें IS 90 माइक्रोन सीव, वेइंग बैलेंस, सीव शेकिंग मशीन या मैनुअल शेकिंग कर सकते हैं, सीमेंट चाहिए होता है। इस टेस्ट में हम 100 ग्राम ऑफ सीमेंट लेते हैं, उसको IS 90 माइक्रोन सीव पे शेक करते हैं। इसकी शेकिंग वहाँ पे 15 मिनट्स तक कंटिन्यू की जाती है। उसके बाद जो सीमेंट रिटर्न करता है IS 90 माइक्रोन सीव पे, उसको वेट करते हैं, तो वो सीमेंट टू द ओरिजिनल वेट ऑफ सीमेंट टेकन, यहाँ से हमें फाइननेस सीमेंट की मिलती है। और ऑर्डिनरी पोर्टलैंड सीमेंट के लिए फाइननेस कभी भी 10% से ज़्यादा नहीं होनी चाहिए। वहीं पोर्टलैंड पोजोलैनिक सीमेंट, लो हीट सीमेंट और रैपिड हार्डनिंग सीमेंट के लिए फाइननेस कभी भी 5% से ज़्यादा नहीं होनी चाहिए। सेकेंड टेस्ट, कंसिस्टेंसी टेस्ट ऑफ सीमेंट। ये टेस्ट किया जाता है ताकि परसेंटेज ऑफ वाटर फाइंड की जा सके जिस परसेंटेज पे स्टैंडर्ड कंसिस्टेंसी प्रोवाइड करे सीमेंट पेस्ट। इसके लिए वीकार्ट एपरेटस चाहिए जो कंसिस्ट करता है मूवेबल रॉड, ग्रेजुएटेड स्केल, नीडल और वीकार्ट्स मोल्ड में। वीकार्ट्स मोल्ड का टॉप डाया 60 mm, बॉटम डाया 70 mm एंड हाइट 40 mm होती है। बात करते हैं प्रोसीजर की। तो प्रोसीजर में 400 ग्राम ऑफ सीमेंट इनिशियली लिया जाता है और उसमें वाटर ऐड किया जाता है 25% बाय वेट ऑफ सीमेंट इनिशियली। इस सीमेंट पेस्ट को वीकार्ट मोल्ड में फिल किया जाता है। उस असेंबली को वीकार्ट एपरेटस के अंडर रखा जाता है जिसमें प्लंजर फिट की होती है 10 mm डाया की, जिसको फ्री फॉल कराया जाता है सीमेंट पेस्ट के ऊपर। वो परसेंटेज जिस पे प्लंजर हमारी टॉप से 33 to 35 mm पेनिट्रेट करे या बॉटम से 5 to 7 mm ऊपर रह जाए, उस परसेंटेज को हम स्टैंडर्ड कंसिस्टेंसी ऑफ वाटर कहते हैं। इस टेस्ट के दौरान गेजिंग टाइम का ध्यान रखना होता है। गेजिंग टाइम वो टाइम होता है जब सीमेंट में वाटर ऐड किया जाता है, वहाँ से लेके जब सीमेंट को हम मोल्ड में डालते हैं। तो ये मिनिमम 3 मिनट्स होना चाहिए एंड मैक्सिमम 5 मिनट्स होना चाहिए। तो गेजिंग टाइम मस्ट बी इन बिटवीन 3 मिनट्स to 5 मिनट्स। अब बात करते हैं सेटिंग टाइम टेस्ट की। इस टेस्ट को परफॉर्म करने के लिए भी वीकार्ट एपरेटस की रिक्वायरमेंट होती है। इस टेस्ट में हम इनिशियल सेटिंग टाइम एंड फाइनल सेटिंग टाइम को फाइंड करते हैं। इनिशियल सेटिंग टाइम की बात करें तो इसका प्रोसीजर सेम रहता है जैसे कंसिस्टेंसी टेस्ट का था, सिर्फ दो चीज़ें रिप्लेस होती है। जो परसेंटेज ऑफ वाटर है वो 0.85 ऑफ पील लिया जाता है, मतलब जो परसेंटेज ऑफ वाटर कंसिस्टेंसी टेस्ट में यूज़ हुई थी उसका 85% ऐड किया जाता है इनिशियल सेटिंग टाइम में। सेकंड, जो प्लंजर 10 mm डाया की यूज़ होती थी कंसिस्टेंसी टेस्ट में, इस टेस्ट में उसको रिप्लेस किया जाता है 1 mm नीडल के साथ जो फ्लैट क्रॉस सेक्शन की होती है। आज सीमेंट पेस्ट को उसी तरीके से बनाया जाता है, वीकार्ट मोल्ड में फिल किया जाता है। उसके बाद उस मोल्ड को पेस्ट के साथ प्लंजर नीडल के नीचे रखा जाता है। तो इनिशियली नीडल जो है वो फुल पेनिट्रेट कर जाती है, पर टाइम के साथ सीमेंट जैसे जैसे सेट होता है वो उसकी पेनिट्रेशन को रेजिस्ट करती है। तो टाइम जिस टाइम पर हमारी जो नीडल है टॉप से 33 to 35 mm पेनिट्रेट करे या बॉटम से 5 to 7 mm टॉप पे रह जाए, उसको हम इनिशियल सेटिंग टाइम कहते हैं। नाउ एज पर इंडियन स्टैंडर्ड्स इनिशियल सेटिंग टाइम जो होता है OPC, ऑर्डिनरी पोर्टलैंड सीमेंट, सल्फेट रेजिस्टिंग सीमेंट, पोर्टलैंड पोजोलाना सीमेंट, रैपिड हार्डनिंग सीमेंट का मिनिमम 30 मिनट्स होना चाहिए। लो हीट सीमेंट का इनिशियल सेटिंग टाइम 60 मिनट्स होता है एंड क्विक सेटिंग सीमेंट का इनिशियल सेटिंग टाइम जो है 5 मिनट्स होता है। गाइस ये कई बार कम्पिटिटिव एग्जाम्स में आ चुके हैं। अब फाइनल सेटिंग टाइम सीमेंट की बात करें तो इसमें सिर्फ नीडल को रिप्लेस किया जाता है और एक नीडल का यूज़ किया जाता है जो सर्कुलर क्रॉस सेक्शन की होती है, जो 0.5 mm प्रोजेक्टेड होती है और 1 mm डायमीटर की होती है। उस नीडल को सीमेंट पेस्ट पे फॉल करा जाता है टाइम के साथ, और जिस टाइम पे वो नीडल सीमेंट पेस्ट पे कोई भी इंप्रेशन मार्क ना कर सके उस टाइम को हम फाइनल सेटिंग टाइम सीमेंट का कहते हैं। तो एज़ पर इंडियन स्टैंडर्ड फाइनल सेटिंग टाइम ऑफ OPC सल्फेट रेजिस्टिंग सीमेंट, पोर्टलैंड पोजोलाना सीमेंट, रैपिड हार्डनिंग पोर्टलैंड सीमेंट, हाई एल्यूमिना सीमेंट शुड नॉट बी मोर देन 10 आवर्स, वेयर एज क्विक सेटिंग सीमेंट का जो फाइनल सेटिंग टाइम है वो 30 मिनट होता है एज़ पर इंडियन स्टैंडर्ड्स। अब बात करते हैं क्रशिंग स्ट्रेंथ टेस्ट ऑफ सीमेंट। इस टेस्ट को किया जाता है ताकि सीमेंट की स्ट्रेंथ मेजर की जा सके। इस टेस्ट में सीमेंट क्यूब्स को बनाया जाता है जिनका साइज 70.06 mm होता है, जिसमें सीमेंट और सैंड का प्रोपोर्शन 1:3 होता है और परसेंटेज ऑफ वाटर इस टेस्ट में P/4+3 ली जाती है, वेयर P इज़ द परसेंटेज ऑफ वाटर जो स्टैंडर्ड कंसिस्टेंसी टेस्ट से हमें मिली थी। सीमेंट क्यूब्स बनाने के बाद 24 आवर्स के बाद उन क्यूब्स को निकाला जाता है और वाटर में रखा जाता है, और वाटर से उनको उसी दिन निकाला जाता है जिस दिन उनकी टेस्टिंग होती है, लाइक 3 डेज़, 7 डेज़ एंड 28 डेज़ टेस्टिंग की जाती है। जो लोड अप्लाई किया जाता है CTM कंप्रेसिव टेस्टिंग मशीन में वो यूनिफॉर्मली अप्लाई किया जाता है @35 न्यूटन पर स्क्वायर mm। अब टेस्ट के बाद मिनिमम कंप्रेसिव स्ट्रेंथ सीमेंट क्यूब्स की अगर 3 डेज स्ट्रेंथ लेते हैं तो इट शुड नेवर बी लेस देन 11.5 न्यूटन पर स्क्वायर mm, और 7 डेज़ की 17.5 न्यूटन पर mm स्क्वायर से कम नहीं होनी चाहिए, और 28 डेज़ की बात करें तो इट शुड नेवर बी लेस देन 25 न्यूटन पर mm स्क्वायर। अब बात करते हैं गाइस साउंडनेस टेस्ट ऑफ सीमेंट की। साउंडनेस का मतलब क्या होता है? एबिलिटी टू रेजिस्ट वॉल्यूम और एक्सपेंशन, कि सीमेंट हार्ड होने के बाद एक्सपेंशन को कितना रेजिस्ट कर सकते हैं, यही चेक करने के लिए ये टेस्ट किया जाता है। अगर सीमेंट ज़्यादा एक्सपैंड होता है तो वो सही क्वालिटी का नहीं है, इसके लिए एपरेटस चाहिए, ली चैटलियर एपरेटस की रिक्वायरमेंट होती है। प्रोसीजर की बात करें तो 100 ग्राम सीमेंट लिया जाता है और इसमें वाटर ऐड किया जाता है 0.78 ऑफ P, वेयर P इज़ द स्टैंडर्ड परसेंटेज ऑफ वाटर जो स्टैंडर्ड कंसिस्टेंसी से मिलता है। इस पेस्ट को मिक्स करने के बाद इस मोल्ड में डाला जाता है जिसका साइज़ 30 mm डाई एंड 30 mm हाइट होती है। इस मोल्ड के टॉप और बॉटम पे ग्लास प्लेट्स डाली जाती हैं। इस पूरी असेंबली को फिर वाटर में डाला जाता है जिसका टेम्परेचर 25 डिग्री सेल्सियस टू 29 डिग्री सेल्सियस के बीच में होना चाहिए। आफ्टर 24 आवर्स इसको वहाँ से निकाला जाता है और इसके बीच में जो इंडिकेटर्स है, जो लेग्स हैं जिनकी लेंथ 165 mm है, इनका डिस्टेंस मेजर किया जाता है, लेंथ ऑफ एक्सपेंशन। उसके बाद इस पूरी असेंबली को पानी में डाला जाता है जिस पानी का टेम्परेचर 25 टू 30 मिनट्स में बॉइलिंग तक पहुंचना चाहिए और 3 आवर्स तक इसको बॉयल किया जाता है। इसके बाद जो डिस्टेंस इंडिकेटर्स के बीच में है वो फिर से मेजर किया जाता है। तो अब साउंडनेस को मेजर कैसे करते हैं? लेंथ एक्सपेंशन आफ्टर बॉइलिंग जो मिलती है हमारे पास माइनस लेंथ ऑफ एक्सपेंशन बिफोर बॉइलिंग, इनका डिफरेंस डिवाइडेड बाई लेंथ ऑफ एक्सपेंशन बिफोर बॉइलिंग मल्टीप्लाई बाई 100। तो यहाँ पे एक परसेंटेज मिलती है। तो दिस परसेंटेज शुड नेवर बी मोर देन 10%। अगर 10% से ज़्यादा है तो मतलब ये सीमेंट ज़्यादा एक्सपैंड करेगा, तो इट इज़ नॉट ऑफ गुड क्वालिटी। बट अगर ये परसेंटेज 10 से कम है तो द सीमेंट विल नॉट एक्सपैंड टू मच आफ्टर हार्डनिंग, सो दिस सीमेंट इज़ ऑफ good quality.
Field test of cement. So we have a good cement should not contain any visible lumps. So yung mga lumps na yan is isang maliliit na nasa loob ng isang bag cement na if the lumps are present in cement, then the cement become useless or the strength decreases. So number 2 is the color of the best cement should be greenish gray. It shows that if the cement are placed in sunlight, the cement shows some greenish color, so that's the good sign of a good cement, or yan yung sign na matibay yung cement natin. So number 3, if you thrust your hands into cement bag, then you will get a cold feeling. So it means that if pinasok mo yung kamay mo sa loob ng cement bag, di ba, mafe-feel natin is malamig siya pag nilagay natin yung kamay natin sa cement bag. So that's the sign of a good cement. Number 4, when you pitch cement and feel between the finger, it should be smooth. Ang minimin na pitch dito is pag piniga natin yung ganito na piga sa kamay between the finger, na mafe-feel natin na smooth yung cement. So that's the good sign of a good cement. So number 5, take some cement and throw it into a bucket full of water. For good cement, the particles should float for some time before they sink. So a good cement should be float on water for a few minutes, while the quality of a cement is directly sink into water because the already absorbed moistures and lumps are presented inside. So ang ibig sabihin nito, pag makita mo yung cement na inimix mo sa water, tapos nag-sink in siya directly, so that's the good sign of a useless cement or weakless cement. Kailangan yung cement, before siya magtatagal muna siya sa tubig, before siya mag-sink in, like minutes or more or less minutes before siya mag-sink in. That's the good sign of a good cement.